Hi, this is our 4180 final project for embedded systems in the fall 2020 semester, and we made a ping pong ball shooter this semester. I'm Neil Narvikar.
Hi, I'm Connor Trudeau.
And I'm Tony Weinman. So for our project, we used a Raspberry Pi 4 and connected it to a LiDAR sensor so that we could get the distancing that the cup was away, and you doubles as you picking the cup that you want to shoot at. And then we also used the camera so that you can line it up horizontally, which also helps in picking the cup you're going to shoot at. And then we used a solenoid and relay to physically hit the ball and push it out of the barrel that we printed using a 3D printer and some CAD we drew up in the Hive, and we used a robotic arm kit with two servo motors to get the horizontal and vertical angles in those 2 degrees of motion. We wrote all of our code in Python, and we used a couple of other Python libraries. And you can see our schematic on the left or on the right, and you can see how we group things in together based off how they were mechanically connected.
So to interface with the system, we made a GUI, and we made this in Python using tkinter. So the first big component we used in the GUI were sliders. So there's a horizontal and vertical slider, which control the horizontal and vertical servo. And then there's also a zoom slider, which controls the zoom of the camera feed. And then in addition, we had buttons. So we had 4 buttons. The first one, start camera, would start the camera. The aim button would then measure the distance from the nearest cup and aim the vertical servo. The fire button would fire the solenoid, launching the ping pong ball, and then exit would shut down the whole system. On this page, we also had a label, and this label updated every second, showing the distance that the time of flight sensor was measuring.
So now that you see what we have, how does it all work? How do we fire a ping pong ball? So first of all, you're going to need to aim the horizontal component yourself using the horizontal slider. Make sure that cup is right in the middle. Press the aim button, put your hand over top the front of the cup that you want to shoot at. So if there's a few in a line, you could also select which cup you're going to go for. The aim function will set the vertical angle to about 10 degrees, take the measurement, and use the data that you can see at the bottom of the screen. This is data we collected on mapping distances away to the vertical angle setting to see how far you need to shoot each ping pong ball. And once it'll calculate that using linear interpolation between our data points, it'll set the vertical angle, and then you're ready to press fire and see the ping pong ball go straight into the cup like you can see on that right side. Amazing.
So as we were doing this project, we had a lot of fun, but there were a couple of things that we noticed we could improve. So the first thing we noticed was that our solenoid wasn't very powerful. So it would have been nice to have a more powerful solenoid with a higher force rating so that we could aim the ball and launch the ball further than we could right now. In addition, we didn't really have a unified power system. We were powering our Pi from the wall and powering the solenoid from a 12-volt LiPo. So if we could unify that power system so they're powered from the same source of power, that'd make things more portable and also would clean up our wiring a bit. And then not the last thing, but another thing we wanted to improve was that the camera feed, we wanted to put a crosshair over it so that the user could aim at the cup more easily, because right now it's a little harder to aim. But we didn't find a super quick way to do this with the Pi camera feed and overlaying it on top of that, so we decided to leave this for a later time.
Sadly, none of us are well versed in computer vision, but if we were and had a bunch of time, we'd love to implement an algorithm to detect different cups and targets. Then you could select which one you wanted, and the computer would find the horizontal angle and the vertical angle to select that target. And finally, we only have aiming for one elevation, the same one shooting at a cup at the same level as the cannon. But if we could have a lot more time to either make a mathematical model or collect a lot of more data for cups at different elevations, we would love to increase the range, but that just did not fit within our time constraints for the semester. But that is it. We had a lot of fun with this project and glad to see what came out of it. Thank you very much for listening and watching, and have a great Christmas break.